Let's look at different kinds of functions. Now, in the previous session, we have seen if a mapping f from A to B is a function, then f associates all elements of set A to elements in set B such that an element of A is associated to a unique element of set B. So based on the above, what we can say is different elements of A to different elements of B, the association. Or we could have more than one element of A associated to the same element of B, or there may be some elements in B which do not have their pre-images in A, or there could be another situation, all elements of B may have their pre-images in A. Okay, so based on these points, we can categorize or we can name the kinds of functions. So let's look at the first one, one-to-one function, also called as injection. A function f A to B is one-to-one if different elements of A have different images in. So the way we would write it is f A to B is one-to-one implies and implied by A is not equal to B. That means there is a one-to-one correspondence between an element of A to element of. Okay, so now how do we check for this? Check for injectivity. How do you check? It is one-to-one. So the first step is take two arbitrary elements A and B in the domain of F. Now, if we say A, B, somehow we may think B belongs to set B. So let's remove that. Let's say A1, A2, right? Because the domain set is capital A. Okay. So now put f of A1 is equal to f of A. Solve f of A1 equal to f of A2. So when you're solving this equation, if the solution arrives at A1 is equal to A2, then the function is one-to-one. Okay. Basically what this means is that if you look at a graph, right? If you look at a graph, let's say y equal to x square plus something. So here you will notice that for a given value of x, there is only one value of y. Some other x, specific value of y. Some other x, a specific value of y. So another way in which we can say a function is one-to-one is if a vertical line crosses the graph, or we also say curve, at only one point. Yes. Okay. Now it is very apparent that if the function is strictly increasing or strictly decreasing, then the function is injective. But for example, if we have a circle kind of thing, so if you look at this, if you draw a vertical line, it crosses the circle at 2 points. That means the equation of the that's why we call it as an equation, not as a. Okay, so that is one-to-one function or injective function. Now let's look at the second one, many-to-one function. A function f a to b is many to one if two or more elements of A have the same image in set B. So here you might have set A, set B, something like this. So this is many to one. Another thing, f A to B is many to one if there exists x comma x1 comma x2 belonging to A such that x1 is not equal to x2, but f of x1 is equal to f of x2. x1 x2 are two distinct values of A. They map to the same element in set. Let's look at the next one, third one, onto function, also called as surjective. A function f a to b is onto function if every element of B is the f image of some element of set A, or we can say if f of A is equal to or range of f is the codomain of f. Codomain is what? Codomain is the all the possible values, that is the entire set B. But within that, range is those specific values which actually maps to a particular value in A. Now, if they both are same, that means what? That every element of B maps to an element of A. So that means there are no leftovers. Okay, so that means there are no elements in B left over. Now how do we check for this? So checking for surjectivity. So choose an arbitrary element B in set B. Put f of A is equal to B, where A belongs to A, B belongs to B. Solve the equation f of A equal to B for A for A and obtain A in terms of B. In terms of B, and let, since we have got it as A equal to, so A is equal to G of B. So for example, we have a f of A equal to B. Now what we have to do is somehow get it in terms of A. So A will be some function of B. So we have to get it in this form. The only thing is the function will not be f now, right? So it has to be a different function. So we say G of. So now once we are done that, if for all values of B belonging to capital B, set B, the values of A obtained from A is equal to G of B are in A, then F is onto. Otherwise, it is in S. So pretty straightforward. F of A equal to B is your normal function, whatever is given to you. You want to check for its subjectivity. You manipulate it in such a way that you get A is equal to some function of B. Let's say it is G of B. Then see whether for all values of A, they are part of or belong to the set A. If yes, then it is okay. Now, let's look at, because we mentioned into, so into functions. Function f A to B is into function if there exists an element B being no pre-image of an element in A. So basically what you have is a situation where you have like this, and this maps to this maps to this maps to this. Remember, this is A, this is B, and now here you have this element which has no pre-image in A. So in this case, this is into. That means there are elements in B which are free. Okay. Here, just corresponding to that. So if you have A and you have these, and let's say you have this, then you have something like this. So you have A, you have B. Each element of B is an image of an element in. So there is, it's not necessary that this be exactly like this. It could be something like this as well. Every element of B has a corresponding value in element in A. So this is into and this is, sorry, this is onto and this is in. Now let's look at what are the numbering. I stopped the numbering. 3. This is 4. Let's look at the 5th. Bijection. That is, in other words, 1 to 1 and onto. That means it is 1 to 1, that is injective, and onto, that means there are no B leftovers. Okay. Now let's see. If f of x is equal to f of, now let's, f of x1 is equal to f of x2, implies x1 is equal to x2 for all this, for all x1 comma x2 belonging to A. That is the first condition. Second is, if for all y belonging to B, exists X belonging to A such that f of x equal to y. So the first condition is to prove 1 to 1. The second condition is for onto. Okay. Now let's look at the next one. Sixth one. 1 to 1 into mapping or function. Of course, the only difference between this and the previous one is that it is 1 to 1 and some elements in B are free, unlike that in the previous one where every element in B has an association with an element in. Next one is many to 1 into mapping. So what does this mean? Multiple elements of A map to the same element in B and some elements in B are free. That means without any association. Or these are the different kinds of functions. That's it.